Hi friends, welcome to another video of quirky Robo-Dog mini. In the previous video we saw this code which was running generically, and you were able to test all the quirky Robo-Dog mini's poses and then finally finalizing and queuing them one after other and then finally playing back, and you see the whole animation happening. So this time in this video we are going to see how the code works. So it's a code walkthrough video, and if you want the code, I will be definitely giving you. Please ping me in the link I will put in my description, and right away I will give you the code. So let's start. So as usual, this is the on flag click. This is the starting point of our project, where I am doing all the initialization or resetting whatever you have done before. So what we are doing. Before going to this, I want to also tell you what are the variables I have declared and using. So you can see I have used for list variable. As you can already guess why for list I am using, because there are 4 legs, 4 list, so there is a relation, right? And you see the name also telling back left state, back right state. So each of these variables are each of this list are taking care of the leg it mentioned. So back left is taking care of every state, what is the position, servo motor position of that particular leg, it is making a note of. So as you can expect, all these 4 arrays or list will be of same length, and the length is the number of state we have incremented here. So number of state is 7. You can reduce 1 because first state is fixed, that is not listed here, which is the 90-degree positions, that is the starting point. Okay, other than that, all the rest of the 6 states will be here. So you see all the list will have 6 entry points, and I will be checking back left 0th entry, back right 0th entry, and all the 0th entry, that is the state 2. Then state 3 is the 1th entry, like that till the 6th. This is the variable. And then this is the state, this is the current state where you are either freezing, or when you are playing back, what is the current state it is going to. This is those variables. These are the currently the encoder position you're experiencing or you're saving. These are that variable. And so what eventually will happen, first we will test it, and then this variable 4 variable will update to the value of servo motor that we are looking for. And then once you freeze it, this will be copied into this 4 list, 1 in each, 1:1. Back left will be in the back left state, then back right in the back right state, and so on. And then he will go increment plus plus. Who is that incremental variable? This is the I, or I think the state. I think state is the variable. So I will say back left state within square bracket state, and then state is starting with 0, and then every time I push one value I will increment the state. That's how it is. So before when I click the flag, this all variable state variable will reset back to 0. This all arrays will reset to, it will empty itself, so that it don't remember the previous thing. So delete all the variables. So what I'm calling on click flag click init all variable and neutral pose will bring all the 4 legs into 90-degree position, and init all variable is where what you can see here. This is removing all the list content. That state variable it's setting to 1. Why not 0? Because the first state is reserved, that is the 90-degree position. And then setting all the leg to 50. Why 50? Why not 90-degree? Because I was using the basic, I was using the slider feature of the variable directly. I don't want it to complicate this by using my own slider sprite kind of thing, like a ball as a sprite, and then so it will be complicated to create my own slider that will support till 180 degree, 0 to 180 degree. By default a slider supports till 100, and I want 0 to 180. So what I did, I mapped each and every point from 0 to 100 to the 0 to 180 degree range. So you know the map variable, right? I'll show you the code. So when you see 90 degree and 90 in the slider value, which actually maps to the center of the degree, which is 90 degree. So when you see the variable is pointing 50, actually it is 90 degree. So yeah, keep this in mind. I would request Stempedia if they can allow us to define the value of starting and ending slider position so that you can use it more freely. Okay, coming to the next variable, next part. So this neutral pose, as you can see, this is the neutral pose function where I am setting all the legs to 90 degree. But how many legs? 8 legs? No, actually how I have connected the expansion board to the Quarky, it may not be same with you. So by default I am setting to 90 degree to all the 8 pins that by default probably you'll be using. You may not be using the 12 servo motor points. So just ensure you're using 1 to 8, anything between 1 to 8, so you can use my code. So I'm resetting everything, but for me 1 2 3 4 is enough because I'm not using 5 6 7 8. So yeah, that's the neutral pose, and this is the default function that you have to call if you're using the expansion board from Quarky. So with that, my green flag click is over, and I have also introduced this broadcast to call this neutral pose. But why? Because anyway, if you click the green flag, this will happen, right? Still again, I have created another hook to call the same function, because if you go to the other sprite, you will not see the function. So looks like the block, the personal block you're using, make a where is that? Make a block, your own function. When you go to other sprite, for example here, and if you go to my block, you won't see them. So where is that my block? My block, you see, you have this activate current motion and all the update, but here I have neutral pose as a function which is appearing under this sprite because I have declared it here. And you can see these are the two functions I have declared under this sprite, but that is not accessible from the other sprites. But what if I want to go to that position or want to call that from a playback sprite? I have to send a broadcast message. That is the currently I see that is the only possible way of calling, instead of redefining the same function or the block to all the sprites. So okay, I'm okay with that, so that's fine. Now coming to this test button. So when you click this test button, on click of that, what happens? We are calling the activate current motion. So what is this activate current motion is doing? It is updating all the legs. I mean, it is updating what is the current position of this 4 legs supposed to be. It is reading from the slider. When I click this test, it is taking what is the current state of these 4 sliders and updating to somewhere. What is that somewhere? Updating to the corresponding pin, the servo motor pin. So S2, S1, S3 and S4 is for me, but when you take it, you can wear it up as per your requirement, like as the Stempedia's manual has shown, S1, S2 and then S6, S5 and S6, not S3 and S4. So if you are following that, then you have to change this to S5 and S6. And remember, this mapping have to be correct. Front left to S2, front S1 to front right, or whatever it is, you just map the mapping correctly. It's not a problem if you do it wrong, because it's the leg. So I mean, you can test it and find it out. Do something that you guess it is. You change that alone, one of them you change at any point of time and click on the test, and you see that leg only will move, and by that you know which leg move is actually connected with that particular servo, and then you change it and make it properly. That's how you can experiment do. But my point is, this is the only place you have to touch after downloading this SB3 file from me. Once you change this one, and you see this is the mapping part. So front leg or the sliders are allowing us to play between 0 to 100, but we want to map this 0 to 100 range to 0 to 180. So this mapping is happening in this block. So anything happens, we are reading from the front leg and finally storing into that S1, S2, S3, S4, whatever the servo variables, that is happening in this function. Be it when you are experimenting, or be it when you are playing back. When you play back, what will happen? What you expect? You would expect okay, freeze means once you are happy with the value, you will just copy it into one of the state, whatever state is available. So the state whatever currently the value is, it will be starting with value 1, because 0 is already reserved, I told you. So currently it is state 1, and then at that that index of the array, I mean if you go to the variable and you see the list variable, and front left, front right, all these things are value which is assigned to the front left state. So the states are the list, and what is the index you want to assign? That is the index, the state number. And once you assign, so that next time you click the freeze and it doesn't override the same location, you have to immediately increase the state index by 1. Then the next state index is 2. So next time you click on the freeze, it will upload in the state value equal to 2. So in this array index, index number 2, it will assign this value. So this is how this works. When you click on the sprite, freeze it. This is the code about freeze it. And yeah, this one I can delete, but I'm just for my experiment purpose, I'm just clicking this to show what are the variables I really see in the array after testing all these things. Means I'm happy with the value, like say state 1, 2, 3, 4 state, or in this case total 6 states and 1 is reserved, so total 5 states. So after finalizing the 5 states and after clicking playback, I'm happy. I can open and see what are the values they are storing, and take a screenshot and share with your community so that you can make your own. You just have to bring it to that position and click on freeze. Or in future we can come up with a CSV file where you can exchange a CSV file instead of giving a screenshot. That will be even better. Okay, so coming to next and the final sprite, the playback. So this playback, as you can already guess, that we have to first start to the neutral position, and that is the 90 degree state 1, and then state 2, 3, 4, 5 all is actually I mean you can say state 0, and then state 1, 2 till the length of the array. That many states it have to iterate. So this repeat block is going to iterate until the length time of the any of the array. I can choose any array out of this 4 array list, the list, and for any, because all of them will be of the same size expected. So till that length it will repeat itself, and every time I will increment that I. So I is starting with 1, and every time it will increment 1, 2, 3, 4. If it is having 6 state in this case, it will start with 1, means position 2, 3, 4, 5 like this, and it will keep iterating. So okay, so that's how I'm repeating, and every time I'm saying assign to right servo pin, and this is the function where I'm saying go to that particular index of the array list and fetch the value into the slider. So immediately you will see the slider got filled with the value. Let me hide it. Immediately you will see when this is happening, right? If you keep a delay here, you just add a delay and see how the things are happening. Immediately after this function is called, you will see the slider got changed to the value, the index we are looking for, and then the broadcast message active current motion broadcast. This will go to, where is that function I defined? I think it is here. Active current motion broadcast, which is ultimately calling this. Okay, so before you update all the servo motor state, how they are getting the value, because you see this update backup, they are again copying that front left, the slider value, and assigning it into the list variable. So if I summarize, when you iterate and repeat all the states one by one, at first state we are fetching the value from the array list for a given index and assigning into the slider. Then we are calling that this function by the broadcast, and he is ensuring from the slider it is copying to the servo motor pin variable. This S1 to S8, that variable I have declared here. It is assigning to those variable, and as per your mapping, whatever you have hard codedly done, only those servos will be touched by the code, and you don't worry about here, because rest of the things will be by default 0 or whatever it is. You don't care because nothing is connected there, and then he will obey that, and every time he does that, and he will go back, and it is taking 1 second. So you can change this to see the animation, how much smooth you want, you can adjust, and then he will go to the next index of all the 4 arrays and iterate the same. So until the whole state are finished, it will repeat itself. Next time again you click playback, it will start from beginning. So the same thing will happen again and again. And outside this repeat block, I am setting it to the 0th state, which is the all the leg 90 degree. Hope you understood. If any doubt, please get back to me, or if you have any suggestion how can I make it more better, more generic, please get back to me. And definitely, as I told you, there is improvement opportunity there. When you click on, you can have a save button. Once you click the save button, all these states from all these variable can be iterated and saved into a CSV file, a single CSV file, by using the data save block. Data logger block. So using the data logger, we can save into a physical CSV file in a path, and then later we can share that path instead of sharing the screenshot. That will be more nice, right? Because if you have multiple states and the state exceeding the screen, the screen provided here, you might go here, but still it might exceed. That's not a clean way of sharing the details. If you share a CSV file, it will be more convenient for others to use your state without doing a single line of code. So yeah, that improvement we can do. If any one of you can do it, need any help, let me know, or try to do by yourself and give it as a gift to the community. With that, thank you so much.